The rotation of the sun is differential rotation, which means the equator of the sun rotates the fastest, and as we move towards the pole of the sun, and the higher latitudes, the sun rotates slower and slower and slower. On the average, the sun's rotation takes about 28 days. Because the sun's magnetic field and the plasma that makes up the sun interact with each other, they both affect each other. So the magnetic fields of the sun affect the plasma, which is charged atoms, what we call ionized matter, and vice versa. So as the sun rotates, its rotation is going to affect the magnetic fields. So the magnetic fields start up being north and south, lined up with the axis of rotation of the sun. And then as time goes on, they get all twisted and warped, and fairly soon they get to be parallel with the equator. And then again, they line up straight up again, and the whole thing starts all over again. This cycle takes 11 years. So every 11 years, the sun's activity goes up and down. When the lines are parallel with the equator, solar activity goes up. There's a lot of sunspots that indicate high solar activity. So every 11 years, we have a solar cycle. This solar cycle was interrupted between 1645 and 1715. We call this period the Maunder period or a Maunder minimum. During this period, there was hardly any sunspots at all. Up and down here is the number of sunspots. This is 0. This is 250 sunspots a day. So they count the number of sunspots daily, and we get these curves here. You can see every 11 years the number of sunspots goes up, and then goes down again, and then goes up again. And this period from maximum to maximum takes 11 years. During this period, the Maunder period, we had a mini ice age on Earth.